Gabriela, can we start? Okay.
Yes, I'm good.
Okay. Boa tarde a todos. Eu sou Tauana
Okay,
Monteiro.
good afternoon, everybody. I am Tauana Monteiro. I work at the National Water Agency in Brazil. I am the advisor to Felipe Sampaio, director. And before we start, I would just like to say a few words about the name. Please put your full name there on the screen so that we can print your certificates and then we can send back to you after the workshop. And I would just like to reinforce briefly that we have a few instruments here that you can use. In your lower bar, you have a globe icon, and there you can choose your language of preference, which you want to hear the workshop in. So it can be English, Portuguese, or you can hear the only the interpretation or only the original language. So you won't hear two audios at the same time. So without further ado, I will let Felipe do the opening here. Good afternoon. Thank you, Tauana. Good afternoon. I greet all of our colleagues here from Ana, Rogério Menescal, Alain. It's great to see you here again, and it's great to be here with you in one more workshop. So, just like Tauana said, I am Felipe Sampaio. I'm the director here of the Water Agency and Basic Sanitation in Brazil. So it's the third time we meet here for a workshop like this, promoted under this partnership between ANA and the Army Corps of Engineers of the United States, USACE, and this agreement has been started since 2021, and it started with the training and courses about dam safeties and subjects that USACE is the best are at, so they are the experts about that. And we have an agreement since the last year dealing about the dam safety trainings and their pertinent legislation and the classification and management of risk that they do over there and their policies to deal with dam safety. So the second seminar took place in September last year. It had the participation of the Service for Conservation of Natural Resources. It is an entity, a public entity in the United States, and they are responsible for the upkeep of all dams. So it's in that opportunity, during that time, we could deal with different types of dams, the portfolio, the characterization and classifications of different policies and directives for planning, protection, construction, and monitoring of those dams that are under NRCS. So today we are meeting again, but this time we're going to deal with the methodology in order to prioritize the interventions in order to increase the dam safety when you have a big portfolio to manage. So in today's workshop, we had a record of attendees. We have more than 700 people enrolled, and that shows the interest that this topic brings to people, you know, because people want to be trained and they want to have a more comprehensive understanding of this subject. And this is one of our goals. We have to train more together, learn together, and work jointly to make sure we have dam safety with implementation and inspection of public policies together with the owners of dams, always thinking about security. So I want to let you know that on the 29th of March, we are going to have the fourth workshop, and we hope to have you here as well. So I wish you all a great day. Thank you so much. Thank you, Director Felipe. And I would like to ask whether or not the Superintendent Alan Vaz has anything he wants to say before we start. Nope, just wanted to say thank you for your presence, you know, for everybody here, being here, and everybody who is linked directly or indirectly to the works that we do with the dams. And thank you to Felipe as well, because it brings such a weight to this workshop. And I would like to highlight that we are together with the Superintendents for Services and Security, with Marcelo Nunes. He's the superintendent over at that section. He's also here, and Rogério Menescal, everybody from ANA. Josimar is also here. He is responsible for inspection. Viviane is also here. So we have a huge team on our side following this agreement with the objective of having you guys here. And we once again have to thank Gabriela, Lyvers, and all of the people from USACE for bringing this knowledge to us. And thank you so much for bringing this focus on training of our technicians, our personnel that works with dam safety, and the public servants that have to deal with a huge number of them. So now the topic will be the absorption of the methodology and the methodology that USACE uses in order to manage risks and define priorities in interventions when you have a huge number of dams in the portfolio. So that is the case here in Brazil. I just wanted to say that one. I don't know if Rogério wants to say anything else. Good afternoon, everybody. I have nothing to say. You just said everything. So I just want to say thank you so much to USACE and other colleagues here. I don't know if you said anything about the numbers of enrollments that we had, and the number was growing up to last night. So that was it. Thank you so much. Thank you, everybody. Now I will pass on the floor to Gabriela. Have a great day.
Good afternoon, everyone. First, I want to thank Anna for inviting us here to present this topic to you. Like Alan and Felipe and Tawana have said, the topic for today is the screening methodology that the Corps of Engineers had used in the past to be able to rank our portfolio of dams so that we could start making decisions from a national perspective. So I'm going to go ahead and share my screen, and I'll start off with the presentation today. There are a lot of people on this webinar. Right now we have a little bit over 450 people, so I will do my best to answer questions. We also have another attendee. His name is Vemini Var online, and he was also involved in this process, so he will also be available for questions. And we'll just do our best to be able to get to everyone. Let me go ahead and share my screen and start the presentation. So let me make sure I have access to the chat while I have, okay. So my name is Gabriela Lyvers. I work with the Risk Management Center for the U.S. Army Corps of Engineers. I'm a structural engineer by trade. My job really, my day-to-day job is really to help the Corps of Engineers manage the risk for the portfolio of dams that we have. We own and operate about 715 dams nationwide. And very similar to Anna, we establish policy and guidance that then is sometimes used by the states to establish their dam safety agencies. So today I'm going to give a little presentation. I'm going to start off with giving you a little bit of the historic perspective as to some of the changes that went on in the Corps of Engineers that led us down the path of having to do this screening of our portfolio of dams, of 715 dams. What that screening looked like, why we did it, the steps that are required to be able to do that screening, the things that we learned, the big takeaways from that process, and then the path forward of what our collaboration with Anna will look like, and then we can open the floor to questions. So the Corps of Engineers, we're organized very similarly as the Brazil Dam Safety Agencies. You know, we have our state agencies, and then we have some federal agencies, and the federal agencies, like the Corps of Engineers, own and operate their dams. And the Corps of Engineers itself is divided by districts and divisions that are based on watersheds. And it used to be, I don't know, 15, 20 years ago, that the decisions that were made by the Corps of Engineers were locally made and locally led. So it was led by the senior managers within that particular watershed. We used to look at dam safety in relation to other benefits that the dams gave to the nation. So for example, if the dam was built for flood risk management, but it was also used for water supply or recreation or hydropower, all of those benefits were balanced equally within the context of what we used to do. Projects were prioritized by benefit to cost ratios in the past. And like I said, that was done on a regional perspective. The way that funds were allocated to these projects was on a first come, first served basis. So as the projects were submitted to headquarters for approval and funding, it was based on who got the study done first, and that's how the funds were allocated for modifications to our existing dams. This type of process created an environment where each regional district was kind of looking out for themselves because, you know, they had to prioritize the work in their own region. And what that led to is a somewhat disconnected approach to dam and levee safety nationwide. So the approach that we used to have was standards-based, so it used our guidance and factors of safety, for example, for design criteria. Whether it met the design criteria or it didn't really evaluate the current condition of the structure in relation to the risk that structure portrayed. And then these acronyms right here, that's just a mention as to the type of report that used to be put together during this process that we used to have 20 years ago. They were called major rehabilitation reports or dam safety assurance reports. So after Katrina, after what happened here in the US, where we had multiple failures of levees during some pretty historic flooding in the area, we also had some regional issues with some dams. We had some dam failures, not Corps-owned dams, but state-managed dams. We realized that we really needed to change and adapt to the changing environment within the infrastructure in our country. We decided that we really couldn't continue to make these decisions on a regional perspective, but we really needed to look at this from a national perspective and be able to make decisions with that kind of context. We needed to get to a point where these decisions were made as a group, as a jointly decided within our senior personnel and decision makers. We also made the decision that all benefits probably shouldn't be looked at on an equal perspective. So they shouldn't be all on the same level. But we decided that life safety really was paramount. So it was really the most important benefit that we were providing with our dams that we own and operate. And the other benefits provided by the dams were really looked at on a secondary perspective. Like I said, our inventory, we started looking at it from a national perspective so that we could prioritize and make decisions from a national perspective. And we switched from a deterministic way of evaluating our dams to a risk-informed decision. And I'll get into that a little bit more here when I explain the screening. Instead of being every region for itself or every office for itself, we really tried to come at these issues of our aging infrastructure and the risk that our dams portrayed from a national perspective, from a joint perspective, where the politics of our country really supported the decisions that we were making as an agency. And that cooperation between our office was really important for the survival of each individual office and for to be able to move forward with dam and levee safety here at the Corps of Engineers. And then our reports also changed, and instead of going from a dam safety assurance report or a major rehabilitation report, we changed it to a dam safety modification report as the decision document. And that really required a lot of additional policy and guidelines to be written. So again, this is kind of a historic perspective of what we did and how we got to where we are today. And the flow chart that you see on the right is very complicated, and there's a lot going on. But I want to highlight that this entire flow chart starts with the screening portfolio risk analysis, which is here in green. Our entire risk-informed process really was defined and started off with this screening analysis, and that's what got us kind of on the path of being able to make risk-informed decisions. So we established that screening portfolio analysis in 2005. That was a multi-year effort that continued until 2011. And then from that moment, we were able to start other actions that allowed us to be able to manage our portfolio from a risk-informed perspective. That including establishing interim risk reduction measures that would allow us to reduce the risk at dams that had the highest risk. And it established a dam safety action classification table that I will explain here in a few slides, that helped us rank our dams in relation to each other so that we could prioritize funding and prioritize actions. In 2009, we started our risk assessments, which include the inspections that we periodically complete at all of our dams, but then it included a risk-informed approach of evaluating failure modes and establishing actions for each dam. So that was started in 2009. And starting in 2008 and then continued in 2009, we established new guidelines and policies for a risk-informed approach. And that is in Engineering Regulation 1156. That is available to the public and you can Google ER 1156 from the Corps of Engineers, and you can download it and read it. But that's really what established the guidelines of how we would evaluate our portfolio through this risk-informed process and not just a deterministic approach. In 2008, that led us to do higher level risk analysis so that we could confirm the dam safety issues that we found through the screening process. Because one of the things that I will portray here during this presentation is that the screening process is really the first level of evaluation, but it really requires some higher level analysis to be able to confirm the conclusions from that screening effort. So those higher level risk analyses were started in 2008. And then in 2010, we started what we call our periodic assessment program, which is a process that our dams are continuously evaluated in a 10-year cycle with inspections and a risk-based failure mode analysis. So again, this flow chart, you can look at it. We can make these slides available to everybody. It really steps you through that process of managing your risk on a program level where you continuously assess your inventory of dams. In that case, for us, it was in a 10-year cycle. And then you establish what the DSAC classification would be for that dam, which is the Dam Safety Action Classification, which allows you to rank the dams in level of priority so that you can prioritize actions, resources, funding, and higher level analysis. All right. So like I said, the purpose of the screening, excuse me, of the screening for portfolio risk analysis. So I'm going to switch and call it SPRA from now on. So the purpose of the SPRA was be able to perform a screening of all 715 Corps of Engineers dam to gather information and establish a relative ranking of risk within our portfolio. Dams would be classified based on the Dam Safety Action Classification chart from a 1 to a 5, where the DSAC 1 dams would be of highest priority and highest risk, and the DSAC 5 dams were deemed to be a normal risk dam and, of course, of the lowest priority for action. This classification would allow us to determine future budgeting and resourcing needs, and would help us to establish a program and an action for the years to come for those items, like I mentioned in the previous screen, of the higher level of analysis, of the periodic inspections and the periodic assessments, and all those follow-on action items. All dams were screened with the same methodology. And today I'll kind of go through the steps of what that entailed and how the Corps of Engineers use that information to make decisions. So this is our Dam Safety Action Classification table. Like I said, it's a DSAC. You can have a DSAC 1, 2, 3, 4, or 5, with DSAC 1s being the highest risk and DSAC 5s being the lowest risk. DSACs 1, 2, and 3 are deemed to have a high enough risk within our inventory to require additional action. So anything that is classified as a DSAC 1, 2, or 3 within the Corps of Engineers portfolio requires a higher level of analysis, of risk evaluation. One of the things that I do want to point out is that the process of classifying the dam it can change with time. So when we started the screening, the SPRA process, it was really, everything was being evaluated at the same playing field. So every dam was being evaluated under the same spreadsheet, so through the same methodology. So the outcome of the screening process was really a relative ranking in risk. What that means is that it wouldn't be applicable for me to compare the risk through the screening process of the USACE inventory and maybe compare that to another inventory outside of our portfolio. So this was meant to be a relative prioritization. We establish more, we have a process to do higher level risk analysis so that we can confirm the outcome of the screening process. So this is just a timeline of the activities that the Corps started when we went from a deterministic approach and from a regionally led approach to a risk-informed approach that was nationally led and nationally prioritized. Like I mentioned, this started in 2005. And the screening went to 2011. And then as we were doing the screening, as we were getting more people involved, as we were getting more people trained, we started being able to add on activities to that process. So in 2010, we started with the levy screening. We at the Corps of Engineers also are involved and have to do screenings of many levies, many miles of levies here in our nation. So in 2010, we started with the levy screenings. Like I said, in 2010, we established what the periodic assessment process would be within our portfolio. So that was that ongoing evaluation of risk for our entire inventory. And then in 2008, we started those higher level analysis that are required if we're going to go into a dam modification. So like I said, the screening is to establish that relative ranking and then to evaluate what the risk is and how you would reduce the risk through a modification of the dam. You would be required to do a higher level risk analysis, which we call an issue evaluation study, and then a dam safety modification study where you actually evaluate how you would modify the dam, how you would rectify the issues at that dam, and how you're reducing risk. So this is, sorry for all the words on this slide, but these are some pretty important guiding principles that the Corps established through that guidance and policy in ER 1156. And those were pretty pivotal to the direction that the program went in, starting back in 2005 and moving from a deterministic approach to a risk-informed approach. So one of the things that was probably highest on the list, and of course is number one here, is that life safety is paramount. So life safety is really the biggest consideration that we take when evaluating a dam. We don't want to increase the risk to the population that lives downstream of the dam just because the dam is there. So it's not, we did not feel like it was appropriate to balance life safety with other benefits to the public that are there because of the dam. So like example, recreation or hydropower or water supply. And for the case of the Corps of Engineers, we established that life safety is the highest priority. The second guideline is do no harm. So if we were to build a dam, we cannot worsen conditions that if the dam was not there. So for example, if we have a river where there's flooding and the Corps decides that they're going to build a dam in that river, we cannot make flooding worse for certain people downstream of that area. So that's one of the considerations that the USACE has to keep in mind, that we do not worsen the conditions for the population. Like I said, we went to a risk-informed corporate approach, so a national approach to dam safety. That means that the decisions in our program are made on a national level and not on a regional level. The public safety responsibility that the Corps of Engineers has requires that we ensure that the projects are adequately safe. So that means that if we believe that one of our dams is not adequately safe, then we have to take action to make it safer and reduce that risk to the population downstream. We do have to acknowledge, though, that as an agency, we can manage flood risk and we can manage inundation, but we are limited to that. There's not an unlimited capacity to be able to manage floods. And that is just a reality of dam evaluation, dam design. All projects and project risk is dynamic and can change over time. So as the dams get older, the risk might increase. As the population changes within a country, the risks might increase. So if you have a dam and population and people move to that area, then your consequences might increase. So it's not appropriate to only evaluate risk one time within the lifetime of the dam, but it's something that you have to do within a cycle, within a certain number of years. It's a continual evaluation of risk. Life loss and economic damages. We do look at economic damages, like I said, but we make decisions based on life safety. But there is a relationship between the two. So usually when life safety when life loss is high, economic damages are also going to be high. And that's normally because your consequences might be within a large population center. The urgency of dam safety actions have to be proportional to the level of risk. What that means is that if you have a high-risk dam, you should be taking action within a timeline that makes sense. You should not take years to make decisions if you have a dam that is a high risk, or to take actions. The Corps of Engineers is to provide risk information to internal and external stakeholders, including the public. So this references the idea that as a federal agency, we have a responsibility to alert the public of the risk that they have from living downstream of a dam. So part of our strategy has to be risk communication and communicating to the population the condition of the dams and, for example, like inundation mapping and those kind of things. So that is something that the Corps has been working on for the last few years to get better on is risk communication. Studies and investigations will be scoped and prioritized with the goal of confirming dam safety issues. So again, you know, when you're doing the screening, you might come up with some dam safety concerns, and then those would need to be evaluated further through the higher level analysis, but those are prioritized within a national level. So we would be looking at the highest risk dams first. And again, that goes back with you should take action that's comparable to the level of risk. If you have a high risk dam, you should take action at those dams first. The risk management measures will be prioritized in a cost-effective and timely manner to reduce risk across the portfolio. So if we have risk at certain locations or at certain projects, we really have the opportunities to manage those risks by implementing actions. And those actions really need to be evaluated from a national perspective if they require funding, and they need to be implemented in a timely manner based on the risk. The level of effort and scope of the assessments is scalable to the appropriate level of confidence that is needed when considering risks and what is needed by the decision makers. So what do I mean here? It kind of goes back to, I think, one of the issues that you're having at ANA and Brazil. If you have a dam where you have potentially more uncertainty than in another dam, but your consequences are very small, you don't have any life safety considerations, you're not cutting off any federal or state highways or anything like that, then you can maybe live with a little bit more uncertainty than in a dam where your consequences can be very high, life loss can be high, your impacts to the economy can be high. So if your consequences are greater at certain dams, you might have to do more evaluation at those dams to reduce the uncertainty and to be able to make decisions and be able to portray the risk to decision makers. Execution of routine dam safety activities is essential. The health of our inventory is only as good as what our routine dam safety activities are, and those really need to be continuous. So maintenance of the structures, instrumentation, monitoring during floods, and just a continual evaluation of the state of our inventory. And then the level of risk.
Greetings, everyone. This is Mr. Coleman, audio check over.
It sounds like, I'm sorry. Sorry, that was on my end. I had something else that just popped up. All right, sorry, I have it muted now. And then the level of risk will be routinely documented and reported. So again, that means that as the risk can change throughout time, that is something that has to be evaluated and documented. Okay, so that is a lot of historic perspective, but I think it helps you understand the context in which the Corps of Engineers created this process for screening. So what exactly is SPRA? So it stands for Screening Portfolio Risk Analysis. And like I said, it provides a relative risk characterization of all the dams in our inventory. It's intended to be an initial rank of the dams based on the DSAC classification, so 1 through 5, and it identifies which dams require additional analysis. The way that we evaluate the dams is based on risk, which is the probability that an event or a load can occur. So whether you have a hydrologic event, so a flood, or a seismic event, so the probability of having that loading, the probability of failure of the structure, so how that structure is going to behave given that loading, the probability that the structure would breach, and then what happens, what are the consequences given that breach? So in this case is exposure and the loss rate. So that together equates consequences. And I'll go into what these mean here in a little bit. So the way that the SPRA was set up, it applies a baseline failure probability for all features within a dam that are typical based on design meeting USACE guidelines for design and construction. And then those are adjusted based on the expected performance of the dam. So what that means is that when we we used a spreadsheet back in the day to do the screening. And when we created a spreadsheet based on the components that you would have on your dam, there was a baseline probability of failure assigned to that component. And then the team that was screening the dam could increase or decrease that baseline probability based on information particular to that dam or to that project that you were evaluating. And I'll explain that again with some examples here in just a minute. So we established this methodology, and we used this methodology again to evaluate all of our dams. And that included dams that were built for flood risk management, navigation dams, which are low head navigation dams, so dams that don't see a big head differential throughout the year, and high head navigation dams that we have in the western side of the country. So there were 6 steps required for this process. The first was establishing the rates and the probabilities of those initiating events, so the loading, so whether it's hydrologic or seismic. Like I said, then we needed to also look at the structure behavior, and we did that through what we called engineering rating data, and I'll explain that here in a minute. I'll go step by step through these, explaining these further. And then once we had the structure behavior evaluated, we determined what our expected dam breach would be and evaluation of the breach severity. And then we evaluated what the loss of life and economic consequences would be given that breach. Then we compiled all that information to complete the risk assessment for that individual dam. And then that information was rolled up to a national database where we could evaluate it from a portfolio perspective. So that's when we would compare the relative ranking of our dams and be able to make decisions of how to prioritize the actions for our inventory. So like I said, I'm going to go through all these steps again. All right, so the way that this was set up was it uses event tree logic to evaluate these steps. So this is just a visual representation of those 6 steps that I had in the previous slide. So we go through the initiating event. In this case, it could be a normal, unusual, or extreme loading condition. So a hydrologic loading, it could be a seismic loading, or you could have, those events could be different depending on your inventory. For us, it was hydrologic and seismic is what we were evaluating our structures against. Then, like I said, you evaluate the structure components through the failure mode probabilities. You evaluate the consequences, and then you calculate what the risk is for the project. All right, so step one, the hazard, the loading, the initiating event. So we looked at 5 different loading events. We first was a normal water level. So this was a hydrologic pool, a hydrologic event, a pool range with a return period of 1 to 10 years. Then we also looked at an unusual water level event, which was a pool range with a return period of 10 to 300 years. And then an extreme water level event, which was a pool loading with a return period of 300 to 10,000 years. And then we also had 2 seismic loadings that we looked at. One was the OBE, which is a return period of 145 years. And then we looked at the maximum design earthquake event, the MDE, which had a return period of 2,500 years. So this was the same, we looked at the same initiating events for our entire portfolio. These were not changed depending on the location of the structure of where you were. All of these were left the same so that you could start with the same initiating event and compare the risk from structure to structure. One of the important things to mention here is that all of this evaluation was based on available information. This did not, at this stage of the risk analysis for our inventory, we did not go and create new information or new data or new analysis for the evaluation and the screening of these structures. This was all available information at our districts, and no new analysis or information was really done or created until we were in a higher level risk evaluation. All right, step 2, the engineering rating data. So this was a subjective evaluation based on existing information. So the team that would do the screening would go to the site, read through all the background information, and then based on the engineering judgment, based on the information that was provided, based on their experience as dam engineers and risk evaluators, they looked at each project component and established a performance given the loading. So for example, if I had, let's say, a normal pool like I had in the previous slide, then I would evaluate each dam component from a performance perspective. So there were four levels that you could choose from. So you could say that the component was adequate. So what that meant is that it was judged to perform well under the specified loading condition with a high level of confidence based on existing data, analysis, or project characteristics. So it was judged to meet current engineering guidelines and criteria. The next one is probably adequate, which it was judged to perform well under specified loading, but the confidence was lower. So it may not specifically meet current guidelines and criteria, but the judgment was that it would likely still perform well under the loading conditions evaluated. So those 5 loading conditions evaluated in the previous slide. It requires additional investigation or studies to confirm adequacy. So again, this additional investigation or study wasn't done at this stage, but it was recorded that there could likely be more information gathered if some additional analysis was done. The next was probably inadequate. So it was judged to not perform well under the specified loading with a low level of confidence and requires additional studies and investigations to confirm. Judged to not meet current criteria. So in this case, we the team that was evaluating would expect that that certain component of the dam would not perform well under that loading criteria. And then and on top of that, there was a low level of confidence. So additional studies would be done. And then the last one was inadequate. So judged to not perform well under the specified loading with a high level of confidence. So they were pretty sure that it would not be able to survive the expected loading. And I'll explain all of this a little bit more. So I know this is a lot to take in. And then there was another that it was not applicable. So maybe if you didn't have that certain component in the dam. So what this looked like, so this is an example of that screen in the spreadsheet that was used to establish that engineering performance. There were predetermined features that were already included in that spreadsheet. And the team would just go in there and evaluate it for the different loading dependent on the feature that you were looking at. And the spreadsheets were all a little bit different depending on the type of dam that you were evaluating. So if you were looking at an embankment dam with a conduit, for example, you would use the flood risk management spreadsheet. If you were looking at a low head navigation dam, like in one of our rivers, you would look at the low head navigation spreadsheet. Or if you would look at a navigation dam out west, one of these high head navigation dams, you would have to switch to a different spreadsheet. And the reason for that is because the project components were already in the spreadsheet and they would change depending on the type of the dam. So what you would do is you would take this spreadsheet, find the component that you wanted to evaluate. So in this case, this example has a concrete gravity section. And you would evaluate it for external stability, internal stability, foundation stability, and foundation seepage and piping. And then you would establish whether you felt it was adequate, probably inadequate, or inadequate, based on each of the 5 loading criteria. So you would go through and evaluate the normal water level, the seismic, the operational basis earthquake, the MDE, the maximum design earthquake, then the unusual hydrologic loading, and then the extreme hydrologic loading. So for each of those, you would fill out and select, using engineering judgment and information that was available at the dam, how you felt, what the team thought was the rating for that component. So each type of dam had different features that were predetermined and loaded onto the spreadsheet. So like I said, for a concrete gravity dam, you would be looking at a certain number of failure modes. For an embankment dam, you would be looking at other failure modes such as seepage and piping, stability under liquefaction, erosion. You would be looking at the abutments and the foundation. If you had a spillway, you would be looking at stability and gate operability and mechanical components. So you did have to think about exactly what the features at the dam that you were going to be, and you use the appropriate spreadsheet. So this is just another example. You would have you could have outlet works, whether you had conduits, whether you had a stilling basin or not, evaluating the reservoir rim, or there was a part in the spreadsheet where you had the ability to add features that were specific to your project. So the way that this would look would be something similar to this. So this is an example that I took from one of the reports. So here the team evaluated this dam X, I don't know what dam it is, and went through all of the components and all the loading criteria and established the performance, the engineering performance, given that loading. So like I said, this is based on engineering judgment, based on information that was available at the site. Sometimes some projects had more information than others. So you had to make sure that you had an experienced team that was evaluating the information that was available and making this determination. All right, so that So then, all right, so here, let me go back a little bit. So here we evaluated what the engineering team decided was the performance of the structure. Like, how would the structure perform under the loading that was expected, right? So those 5 different loading scenarios that were evaluated for our entire inventory. This next slide is that, so a few minutes ago, I said that this spreadsheet established a baseline probability of failure for each project component. So the way that this worked is that you would start off with a base probability for that component. And then based on the performance that was established by the team, that baseline probability was modified. So it was, if it was adequate, so if the team deemed the feature to be adequate, so it met design criteria and performance criteria for the core, then the baseline probability was, then the probability of failure was equal to the baseline. No modifications were made. But if the team felt like it was probably adequate, probably inadequate, or inadequate, then that baseline probability was increased to account for the expected performance by the team. So hopefully that makes sense. So the team evaluated what they believe the performance of the component would be. And then based on that answer, the baseline probability of failure would be modified. So let me give you an example. Let's say that I was evaluating a concrete dam, and I was evaluating external stability. So I was doing a stability analysis for the monolith. I went back and looked at all their design information, looked at, let's say we had new field investigations and we had new boring information, and I agreed with all their design criteria. And I said, okay, well, this met the standards at the time of construction. It meets our standards today. Given this, let's say it's a low seismic area. Given this, I think that the structure is adequate based on all of the loading conditions that we're evaluating. So then the baseline probability that would be assigned to that concrete section would be multiplied by 1. But in the same dam, I could be looking at a gate, and let's say the gate wasn't designed to our guidance criteria like it is today. Let's say it was, who knows? There could be many things. Like one of the things, like let's say they left out one of the loading conditions that we evaluated in our design criteria today. So there's a question that potentially there could be an issue under these more extreme loading conditions. So then for an unusual loading condition or an extreme loading condition, I can say that it would be probably inadequate. And then that baseline probability of failure for that gate would be increased, in this case, by 100. All right, so then that takes us to step 3. So step 1 was the loading. So we established what the loading was, and for all the dams. Step 2 was the performance of the structure. So we did that through the engineering judgment of performance, and then comparing that to a baseline probability and modifying it based on that performance judgment. And now step 3 is the breach severity. So here we have different, I guess, let me, how do I say this? You could have multiple breach scenarios that were included that you needed to evaluate. The first one is none, so you would have no breach. The second was minor. What that meant is that you could have a breach that results in a release of water from the reservoir, but it can mainly be controlled. So a good example of that would be a gate failure that doesn't inundate anybody downstream. You have emergency bulkheads that you can put in. So something that can be generally controlled within the standard operating procedures of the dam. A major breach would be a breach that results in a complete controlled release of the reservoir. So major breaches are rapidly developing loss of a project feature that releases a significant amount of reservoir storage. So an example of this, it's controlled because it's controlled within a certain certain area. So like I say, let's say it's specific to the spillway. And an example would be if you have a pier failure. So it's controlled because that's not going to grow anymore. It's going to be in that area only, but it does lead to consequences downstream. And then the last type of breach is a catastrophic breach, where the breach occurs that results in complete uncontrolled loss of the reservoir. Catastrophic breaches are rapidly developing dam breaks that extend the full height of the dam. An example of a catastrophic breach could be a breach of an embankment dam that as time progresses, it just keeps getting worse and worse. It can't be stopped, and it keeps growing until the reservoir, all the water in the reservoir has been let out. So these 4 breach severities were used for every project as well. So this was in a spreadsheet with some suggested probabilities for each component. So for example, you had suggested probabilities for a concrete structure, you had suggested probabilities for an embankment, and you could change these probabilities by, like, so the team could adjust these probabilities, but what we would ask is that there had to be justification to make those changes. It wouldn't be something that you would automatically just change. There had to be a justification, an explanation. And if you didn't have that, you should just use the default values. All right, so this is another screen of the spreadsheet that gives you an example of what was shown or what I just went through in steps 2 and 3. So in this step, so in this screen right here, you can see that, so in this case, everything related to a concrete structure is zeroed out. So there probably wasn't a concrete structure in this case. So here we have, let's use the gate. That's a good example. So gates and gate structures. So here we have these base probabilities. We have the modifiers based on the engineering judgment of the performance of the structure. And these are automatically populated by the spreadsheet. There was a head differential calculated, return period of the load in which that was being evaluated, and then the minor, major, and catastrophic probabilities for breach severity. And this is the type of screen that you would see for every component of the dam. So as you're going through the spreadsheet and filling out the performance criteria and the loading and the breach severity, then you would go to this screen and it would show you how everything had been populated. All right, step 4 is consequences. So we do evaluate life loss and economic damages to property and the project. Although, like I mentioned, life safety is paramount, so the decisions for action and prioritization are based on life safety. The economic damages were based on historic data or flood damage reduction studies. So that was, again, all existing information that we already had for each of our dams. And then the life loss was based on fatality rates for the population at risk. So I'll explain that here in just a little bit. So the way that we did our life loss estimates for the screening is that it was based on dam break studies and inundation mapping for sunny day and flood events. So what that means, the sunny day event would be like a normal pool and you have a failure of the dam or dam component that leads to a breach and inundation downstream. So that's the sunny day. And then a flood event would be an event where you have an event that has led to a higher pool within your structure, and you have poor performance of your component, you breach, and then you have an inundation downstream. So life loss can be estimated using predetermined fatality rates. So I have just the table that was used back then when we did it for the Corps, or site-specific information if it was available to that dam. But it was not common that we had site-specific information for every dam that we used or every dam that we evaluated. So we would look at information based on this table here, based on the flood severity, based on warning time, and based on the understanding of the severity of the flood by the population downstream. And then that gave you suggested fatality rates that you would then multiply by the population at risk. So consequences estimated for the catastrophic breach only, and then it was modified for other events. So again, this is with those multipliers. We would establish what the life loss consequences were when we had a catastrophic failure. So that had a modifier of 1, but then the consequences were reduced if we had a major breach severity or a minor breach severity. And again, this was all within the spreadsheet. But I think when you see kind of the process that we went through, you can better understand why this is a relative ranking. So some of it is subjective, some of it is determined by these modifiers, some of it is determined by these methodologies of using tables to establish fatality rates. So all of that, all of those assumptions can change under a higher level risk analysis. But to start, you need to know how to evaluate your inventory when you have that many dams. So again, this was used so that we could have a relative ranking of our portfolio and then go into those with that were the highest risk dams and evaluate further for more precise information. All right, so step 5 was the risk assessment. So conditional failure probability for each load case are automatically computed by the spreadsheet. And then the spreadsheet would calculate an annual life loss and economic consequences for each branch and then added to the total risk of the project. So I'm going to go back here a little bit. Sorry about this. I probably should have copied it in. So that's this down here where everything is being multiplied and added so that you can calculate the total risk for the project and the annual life lost. All right, and again, this was done by the spreadsheet. It was all just automatically calculated once you went in and added in all the information for all the steps previous to this step 5. And then what the spreadsheet would give you, it would give you what your life and economic annual risks were. So in this case, red is life safety risk, and the green is the economic risk. Here on the right is the normalized life safety risk and the normalized economic risk. And then the color coding is the load cases. So what this is telling you is, it gives you an ability to see what is driving your risk. Is your risk driven by more extreme load cases or a normal load case or an unusual load case? So it can tell you information as to what is, where the risk is coming from for your dam. And then the spreadsheet would also give you the annual life risk based on the failure mode that was evaluated. So in this case, the highest risk was due to erodibility, and then hydrologic under the unusual case. All right, so the way that the Corps did it is that every year they had a roll up. They called it a roll up. They had this meeting where they looked at all the results from that year from all the screenings, and then evaluated them for consistency. And that team that did the roll up was a multidiscipline team with multiple districts, so multiple of those regional offices, senior leaders within the Risk Management Center and headquarters. And they evaluated the screenings that had been done that year, like I said, for consistency, and then also to look at the portfolio to be able to evaluate and make decisions. So what this shows right now on the screen is just a graphical summary of the output for each dam that was evaluated. And like I said, it's so here you can start seeing the relative risk that you have within your inventory and how you're able to prioritize action within the inventory of dams. So in this case, this red, this was all color coded just based on like natural shifts within the data. So anything that fell within this red region was evaluated, was deemed to be a DSAC 1 and highest risk. And then everything that was in this yellow was a DSAC 2, and then so on. And that's how the DSAC classifications were set. This red was deemed to be unsafe, and action to remediate was urgent and compelling, which is what a DSAC 1 classified dam means. So as you went up and to the right in this graph, the risks were increasing. So you can easily see which dams are the highest risk within your inventory and where you should prioritize resources and funding and higher level analysis. All right, so that I know that was a lot, and like I said, we'll provide these slides and we can provide some more information, but I wanted to give you kind of an idea of how we did this on a national perspective and how we kept it consistent within the teams and within the different regions of the Corps of Engineers. So that's why a lot of it was built into the spreadsheet using modifiers based on information that the engineering team was providing. But there were also some things that the Corps did from a national perspective to be able to establish this kind of program. And I want to go through some of these here in this slide. So the Corps implemented a national group to manage portfolio risk. That's how the Risk Management Center was born within the Corps of Engineers. It's kind of an arm of headquarters, and they're kind of like they support headquarters decision making. They provide advice to headquarters, and we're not attached to any of the regional offices. So, we were making this big shift and going from a regional perspective to a national perspective. So it was important to the Corps to have an unbiased group of people that would be able to manage this process. So that's kind of how the Risk Management Center came to be. Again, it was national prioritization of actions to reduce risk and to establish actions and new studies to confirm what had been evaluated through the screening process. We did use regional teams to evaluate all these dams. We evaluated about 75 per year. Like I said, we started this process in 2005, and it took us until 2011 to finish. So the first few years was slower, and then as we went on, we got a little bit better. We had bigger teams, we had more people trained, so we were able to to evaluate more dams, but on average, it was about 75 a year that we were able to evaluate. We started with 3 regional teams doing these evaluations, and then that grew to 11 regional teams. I have this check in here. I forgot to delete it. I believe it grew to 11. I saw 13 in a slide, but I think it was 11. And then, like I said, we had those roll-up teams that met once a year that were more of the senior leaders in management and people with more seniority that were evaluating the results of those screening teams. The level of effort, I wanted to talk a little bit about that because I think that would be important to ANA and to the state dam safety departments. It was usually about 4 hours per dam. And for more complex dams, it was about a day. Like I said, this was not an in-depth evaluation of all information. It was evaluation of the most important information through this established process for a very defined set of loading and a very defined set of criteria. That is the only way that really we were able to do that in a 4-hour period or a 1-day, 8-hour period. The teams usually would go out on a weekly basis. So each week they would be able to look at 4 or 5 dams, depending on the level of complexity on each of those dams. So they would go to one regional office where they would evaluate multiple dams for that week. One of the things that did this require was a national approach to inundation mapping requirements. So we all had to have a common approach if we were going to be able to use inundation mapping to do these screenings. So that was some new policy and guidance that was established by the Corps of Engineers. It also required a parallel effort by those regional offices to manage their records, to find digital and hard copies of all the background information and make that available to the teams. In the Corps, through this time, through this 10-year process, or 10-year timeline that we established this risk-informed process, there was also a really big push to digitize all of our records. So districts were making this really big effort to go through all their records, go through all their databases, find any information that was pertinent to the dam, and digitize all those records. That was not always done at the same time as the SPRA. So the SPRA team might be working with digital copies or hard copies, but it was a really essential portion of the work that was these regional offices to be able to find all the historic records that they had. Again, we did those yearly roll-ups for comparison, quality, and consistency, which was really essential to make sure that the teams were evaluating dams in a consistent way and that we could therefore make decisions based on the portfolio. So if you're not evaluating dams in a consistent way, if you don't have that consistency across the teams that are doing these engineering judgment-based screenings, then you really can't make decisions on a national or kind of all-encompassing level. So that was really an important step in this process. This methodology was peer-reviewed by external partners, so we could get buy-in from the agency and from the engineering community of the process that we were doing to evaluate our dams and rank them for prioritization. Like I said, we also had to establish new guidance and policies. So you had new guidance when it came to risk communication. We put together that ER 1156, so that established our risk process. And then we also had new guidelines and interim risk reduction measures, which what that means is what actions can we take to reduce risk in the quickest way possible. And then at the same time, we did beta testing for methodology and processes for our periodic assessment and the risk studies. So like I said, the screening process was a component of our methodology to change from a deterministic perspective to a risk-informed perspective. The screening process was the first tier, and we had to establish where we wanted to go from there to be able to establish that methodology, how we were going to use that information, what steps we were going to take for action and to reduce risk, and to be able to document all these findings. So a lot of that testing of the methodology, writing documentation, getting it reviewed was done during the time that the screening was also ongoing. All right, so that's a very 30,000 foot overview of what our process was. And I know it's a lot to take in, so I appreciate everybody listening. Hopefully it gave you an understanding of how it was set up, why we set it up a certain way, how we used it to make decisions, and how we used it within our goals to be able to establish a national dam safety program that was prioritized nationally. Of course, there are lessons learned. We had lots of lessons learned through this process, and I have a few here that I would like to present to you. So public safety was our first priority. I've said that a couple times in this presentation, and it led to changes in our USACE policy. So we had to be ready to be able to document those changes and release new guidance that was in accordance with our new processes that we were establishing. There was national prioritization instead of regional prioritization, but that really led us to a better understanding of the risk across our portfolio, and it really led to better decision-making by our senior leaders, and not better, I should really say more informed decision-making by our senior leaders. A regional dam safety office had to become complacent with issues. And what that means is that when you're used to seeing your structures in a certain light, when you're used to seeing certain things every day on a daily basis, maybe you don't understand the risk of those issues, or the complexities of those issues, or what actions you should be taking, or how your dam compares to other dams. That national perspective was really important, because I think that when you're set up in regional offices, you're really trying to fix your problems within, right? And you get to a point where you're trying to just do what you can with what you have. And that's not really a good approach when it comes to dam safety. We need to make sure that we're meeting safety guidelines, national safety guidelines across the board, and that all of our dams are safe within the guidelines that we have for the federal structures. So we found that just these regional offices had just gotten used to the issues that their dams had. So bringing an unbiased eye to problems really led to maybe different approaches to fix things and a different perspective. Several projects were found to be in the continuum of failure. So we found several dams that we thought were very high risk were classified as DSAC 1s and led to immediate action by the dam safety managers. There was a disparity in level of funding and investigation for dam safety deficiencies noted from project to project. So again, this goes back to just not having a consistent approach from a national perspective. So one region might decide to fix a problem in a certain way, and another region might decide to fix a problem in a different way. And if the risk is the same, we really should be doing things similarly. We should be providing the same level of funding, the same level of support, and we should be trying to reduce risks with the same targets in mind. So not having that national perspective really hurts you because you can make different decisions depending on where you're located. We had a lot of difficulty finding original dam design documents. I think this is a problem that the majority of agencies have. The dams can be, 50, 60, 70 years old, and finding those historic documents can be difficult. So it was a really eye-opening experience to be able to have to go through that and digitize all those records and really come up with a records management plan. That independent screening identified some significant safety issues. So again, bringing a new set of eyes to old problems can really be pretty eye-opening and can lead to a lot of new information. Broad issues with the state and quality of emergency action plans. So we found that required documentation to be compliant within our safety program was at different levels depending on which dam it was. So we found that we really had an issue with the quality of our EAPs. We had issues with water control manuals. They weren't always explicit with how the dam should be operated under extreme floods, which is concerning because then that means that people are making decisions under stressful situations, which you don't want to be in. So you want to make sure that you have the operating procedures for the expected loads, even if they are extreme. We felt like we needed to do a better job in collecting lessons learned when it came to design and construction of our dams. We needed to do a better job in monitoring performance data to verify future actions. It became really important that we needed to communicate our findings to the engineers out in the field, that this should not just be a process that we did on a computer in the office, that the findings needed to be distributed widely. Ensure we are coordinating properly with other agencies and owners. So again, that comes down to risk communication. We want to be a transparent organization that really highlights the safety of our structures and that there is a good understanding of in the community. And then we really needed to improve really not just how hydrologic deficiencies are documented, but just all deficiencies are documented. So I wanted to present, and I'm not going to go into a whole lot of detail here, but I wanted to present what the screening process would look like today if this was something that we were starting today. We are in the process. So like I said, we also screen levees nationwide. And there are thousands and thousands of miles of levees that we have to screen. So we have what we call the LST. It's the levee screening tool. So I wanted to show you a few screenshots of the screening tool because it's really set up to do the same thing that a spreadsheet would do, but it's a much friendlier user interface. And then you're not dealing with all the issues with a spreadsheet and having to roll up all that information. And especially if you have a lot of dams like you guys have, something like this would probably be more manageable, although it would probably take longer to implement on the front end, but it would give you probably a more manageable product at the end. But this is what the LST looks like. Again, the levee screening tool. You put in the levee information, you have all these different tabs for all the information. And I'm not going into the specifics. I've actually never worked on the levee screening tool. But this is just an example of what we've done with a very similar process on the levee side than what we did on the dam side. So you would put the basic information of the structure, the basic information of the people that are advising the team and the team members. Here you have a screen where you're putting in the loading information. The next screen is where you put in consequences. So it's set up as tables where you can just do data entry. The user can put in the data themselves. Here you have the performance. And again, it's set up where you have different failure modes related to different parts of the dam or the levee in this case. You could have a baseline probability like we showed you on the spreadsheet. Here they have a the annual probability of failure, the consequence location, you know, so this can be, it can be made to look like, made applicable, I should say, for the dam safety side. And then it does all the calculations for breach, and it ranges in those breach and that breach severity and the loss of life. And then it summarizes all the information that for all the failure modes evaluated. So again, this is just an example of what we would likely do today if we were going through this process. Although, you know, the spreadsheet worked well, it was a successful program that really led us to where we are today in risk evaluation. And it really established the starting point, like I said, for us to be able to rank our dams and be able to prioritize decisions for the inventory. So, you know, the reason why we wanted to give this presentation is because, you know, we have this collaboration with Anna, and we're in the process right now of literature review and really understanding the dam safety guidelines that you have nationally, and your dam hazard classifications. And then Anna has asked us to establish a similar methodology and criteria for screening of dams. That way it could be used internally to prioritize funding, action, resources, really whatever decision you need to make as an agency to prioritize action. So we wanted to present what we did in the core as an example, but of course, the way that it was established in the core, it really represented the needs that we had as an agency and in the inventory that we had. So it's really important for us to understand the needs that Anna has, the needs that the inventory has, and really the struggle as a dam safety program that we would really want to remediate through this process. So again, so we're doing this literature review so that we can establish this methodology. We're going to develop some kind of screening spreadsheet program or process and a documentation to go with it. And then the plan is to do an in-country case study of the screening methodology and the outcome. So that is all I had for today. I know it's a lot, and I appreciate everybody's attention. And now we will go back to the web meeting and open the discussion for questions.
Obrigada, Gabriela. Nós agrupamos algumas perguntas.
Thank you, Gabriela. We did group a few questions in blocks. So I will ask you the questions in Portuguese, and you will hear that from the interpreter in English. And then we can go to the following block. So first block, we will start with the question from Ingrid. The reference rates for values in order to assess the risk, are they equal for dams of different sizes or that are closer to cities? Second question from Pedro. The risk assessment, can it be used to monitor the sediment reservoirs? Third question from Stephanie. When a dam is classified as a high-risk dam, do you analyze the risk downstream, and how do you consider that possibility in a broader scale? Renato asked, what is the procedure for emergencies when the dam presents some pathologies in the concrete? And then you can answer that, and then we go to the second block.
Okay, do you mind repeating the last one for me?
Qual o procedimento
What is the
emergencial?
procedure? What is the emergency procedure when the dam presents pathologies in the concrete?
Okay. All right, so I'll try to answer all those questions. So I think first of all, all right, let me see if I can remember all of them. So really it can be the spreadsheet, the process can be used to evaluate any failure mode that is controlling in your inventory, right? So we set it up to evaluate the embankments, evaluate the concrete, the spillways, evaluate gates, evaluate intake towers and conduits. Sedimentation is not a risk driver for the majority of our dams here in the US, so it wasn't included in the spreadsheet, but it certainly can. That's when I think it would be really important for us to understand what's driving risk in your inventory so that we can accommodate those type of differences between our portfolio and your portfolio. The base probability, that is, I'm trying to remember what that question was. So the way that the base probability is calculated, it is based on assuming that the loading is there. So you assume that the structure is loaded, you have a base probability of failure, and that is modified based on that engineering judgment on the performance of the structure. And it's really independent of the consequences downstream. So first you evaluate how the structure performs under that loading, then you evaluate what the consequences are, and then you combine those to calculate the risk of the structure. But the consequences are really, the number of consequences is not dependent on how high or low the probability of failure is. Of course, consequences don't exist if the failure doesn't occur, but the evaluation of the failure is independent on the number of consequences. I hope that makes sense. The hazard classification for our dams, the way that we do it here in the US is that any dam that has any life loss downstream is automatically classified as a high hazard dam. No other requirements are needed to be a high hazard dam. So all of our dams that were screened were high hazard dams. And actually, no, I shouldn't say that. That is incorrect. We have high hazard dams and significant hazard dams. So the majority of our navigation dams are significant hazard, which means that there is no life safety issues. And we used the screening process to evaluate significant hazard dams and high hazard dams. The concrete question, I'm assuming that you're talking about like ASR, like alkali silica reaction. And that is not something, like we have that issue and we have it in very specific regions of the US. And you could add that as one of the features that you're evaluating, or you can make adjustments in the spreadsheet to add these oddball issues, but it wasn't included in one of the major categories that all dams would have been evaluated by. So that's why if I'm going to share my screen again. So you could add features for different considerations that are specific to certain projects if you needed to. But we kept this above portion to be the most common features at all of our structures, or common features and issues. So I think that was all the questions, Tawana.
Ok, vamos agora para bloco sobre perguntas de perdas de vidas, complementando.
So we're going to have a block of questions involving the loss of life. The first one, what is the criteria used to define the population at risk? The height, the speed, what are the criteria? The second question, it's not clear to me the concept of life loss per year, since the events are usually temporary and they only happen at certain moments. And so how do you quantify the consequences related to the loss of life? How do you quantify loss of life?
Okay. Vimini, I don't know, like I can answer one, but you would probably be able to give them a better answer. Do you want to answer them or do you want me to do it?
Hey, Gabrielle, you probably have to answer that because I'm on the phone because my audio of the computer was off. So
Okay.
all I understood was Portuguese there. So sorry.
Okay. All right, no problem. So the question was criteria used to define population at risk. So the population at risk was evaluated through the inundation mapping for the sunny day and the flood condition breach. So the sunny day was a normal pool where you would have a breach. So like it would happen on any day, right? And then the flood condition was, I think, top of flood control pool, I believe. And then with a breach, and then you see what your inundation is and the population that would be impacted. So then based on that population at risk, then you compare that with the different fatality rates that you had in that table. The concept of life loss per year, it's just an annualized number so that you can compare each failure mode to each other and then each dam to each other, because all the loadings have different return periods. So you would be comparing a normal pool with an unusual or an extreme. So you annualize it so that you can compare and see what is driving risk. So it doesn't like the numbers are usually quite small. So like our guideline is usually anything below 1 × 10⁻⁴ is deemed to be
You have
below.
to say that a little slower, a little slower. What is the number, please?
Okay, 1 × 10⁻⁴ would be deemed to meet our tolerable risk guidelines. And that's because it's an annualized number.
Ok. Mais bloco.
Another block of questions. So when the risks are well collected and quantified, how can you collect the resources and how do you manage the resources or funds? That's question number 1. Now, some questions about recurrence. Just a minute, which database of events do you have that was used to define the probability and the frequency? Now a question from Isabelle. How do you collect the data regarding the return or recurrence events that you mentioned between 300 years and 1,000 years or 10,000 years? It's not clear the level of storage, so shouldn't... I'm just asking her to repeat the last question. Just a second, please. Sorry, Gabriela, she was too fast. I couldn't understand the last question. And she's not responding to me. She's not in the translation channel. Oh, sorry.
Okay, so I think I understand the type of question. So I'll just go ahead and answer them. So the first one was about funds and management of personnel. So the way that this was done is we used these regional teams. So they were managed locally by their regional offices. but the central office, so the Risk Management Center and headquarters, provided funding to do the screening. And we did all the quality control and oversight. So we didn't hire all these people to our part of the organization. We just provided the funding, and they were managed locally, but they were doing the work for this national prioritization of our inventory. When it comes to the database of events and frequencies and return periods, so this was, like I said, it was all existing information that we had for our dams. And I wouldn't get too bogged down on that, because it would really need to be dependent on the type of information that you guys have. So what I really want to explain is that what we tried to establish is what a normal pool elevation is, what an unusual pool elevation is, and what an extreme pool elevation is. So it might be that, you know, the extreme would give us information on whether the dam overtops, whether the dam is under-designed. The unusual condition would give us information on how the dam performs under some kind of flood loading. And then the normal pool gives us information about how the dam performs under expected loading on a day-to-day basis. So again, this was put together based on the information that we had available to us. We had frequency curve for all of our dams. So having this information was not uncommon. So we could look at these return periods and establish what these pool elevations were, but with the intent of having an understanding of how the dam performs under those criteria. So under an everyday scenario, under a flood scenario, and under an extreme and potentially like overtopping scenario, or whether the dam would overtop, like if it's under designed, if that makes sense.
Mais um bloco, então. Considerando que o portfólio
Considering that the dam portfolio is formed by a considerable number of old dams, and they do not fit into any criteria, would it be possible to divide the portfolio between really old dams and newer dams? Or would it be more efficient to use the traditional methodology as the one applied by USACE to classify your portfolio?
So this,
Okay.
Oh, I'm sorry, is there another question? Sorry.
There's another one. De que forma foi considerado?
How did you consider the filling in of the spreadsheets to classify the dams, the uncertainty levels of the technical information given to you, and that were considered in the risk analysis of each structure?
So, okay, so the first question is, so the reason why we didn't take the dam age specifically put it into the criteria to evaluate it in a different way is because the majority of our dams like have an average age of like 60 years. But we do have dams that are older than that. And I think that we have to remember too, that the first group that did this, it was 3 teams. It was a pretty experienced group of engineers that they could look at the design criteria, the information, and the data that was available on the performance of the dam, and then make these engineering judgments. I don't really have a good answer as to if that would be the best approach in Brazil. I would think that it could be. I would want to stay away from having different criteria from new dams versus old dams. And I would just keep in in perspective that what we're trying to evaluate is the current condition and the current risk. But again, that's my personal opinion based on the information that I have right now. If I start looking into the inventory and some of the examples that you might have, maybe I would feel differently. But I don't think I would want to make that distinction, because we are comparing it to each other, and we want to understand what the highest risk dams are. And then the second question is, how did you consider uncertainty with filling out the spreadsheet? And again, this was a process that built upon itself. So it started with a small group of dams, with a really very experienced group of people that evaluated the information that they had and used engineering judgment to establish these performance criteria. We did a lot of training. We did a lot of outreach. Those roll-ups, like I said, for consistency were very important, where there was a lot of discussion on this type of information. And there were dams where we didn't have the level of data that we would for another dam. And I guess the only thing I can say to that is, when there is a lot of uncertainty, your estimate is likely going to be more conservative. And then that is something that you would have to evaluate through further study later on when you're able to gather more information. But I think the important thing is to make sure that you have an experienced group that's doing that first evaluation, where they can take into account not just the historic information, but also the performance and current condition of the structure.
Ok. Pergunta do Josimar. Na etapa
One
6,
question from Mr. Josimar. In step 6, when you mentioned the risk portfolio, if each point represents one dam, how is the risk of all of the items of the dam consolidated to place it on that chart? Did you use the risk of each separate structure, or did you add all of the risks in that final colorful chart? What is your opinion about the as low as reasonably practical approach applied to a dam in general? So the data included in the LST, they were opened at a certain level to the population, or shown to the population, so that they could discover the risk they were at? And this could this also become a communication approach? And the last question, are there technical criteria with procedures to manage emergencies whenever there is a rupture or a breach, and the emergencies and the problems start happening like a waterfall, one after the other?
Okay. So the risk portfolio, so this slide, that is the total risk for the dam. So each point is one dam. So the probability of failure and risk for each component of the dam is multiplied through like event tree logic, and then added together to calculate that total risk. So here, you're basically just comparing dam to dam, not component to component. And the risk is driven, it can be driven by one component, or it can be driven by multiple components, depending on the dam. What do I think of ALARP and as low as reasonably practicable? So, you know, we evaluate our dams against the tolerable risk guidelines. And then when we get them below the tolerable risk guideline, that's when as low as reasonably practicable comes into play. So how much you reduce risk based on the cost of implementing those risk reduction measures. So there are criteria that we follow. It's documented within our guidance. We use it under specific considerations, but we don't, like, I'm not really sure I understand the question. Like, we do use it. but it's mostly when we're implementing modifications. All right, the LST. The LST is not open to the public, and it is only open to the people that are within the levee safety program doing the assessments. So it's a tool to capture all the screening that we're doing and all the data related to the screening, but it is not used as a risk communication tool. And within the core, our, we, like even this would probably not be put out to like wide distribution in the public. We have specific fact sheets that we release to the public for each particular dam that discusses inundation and the risk of the structure and what's failure modes are driving that risk. And then we provide inundation mapping to emergency responders for emergency planning. So when you have flooding in the area, and I don't know exactly how this would transfer to failures in series, but there are requirements for our dams to have tabletop exercises with the emergency responders within the region of the dam, so that they have an understanding of what the performance of the dam is expected to be under certain loadings, and what the inundation would look like under if it were to breach, how far the inundation would go, and in that case, it would include whether it could lead to failures of other dams downstream. So they would have that information prior to a failure, prior to the emergency, and I believe that those have to occur within our inventory every 5 years. If anybody from the Corps is on that knows that answer for sure, let me know if that is incorrect. But those tabletop exercises occur on this reoccurring basis to keep the emergency responders up to date on anything that has changed for that dam in particular. So, Josimar, I hope that answered your questions.
As últimas três agora.
Last three questions then. First of all, how to proceed in the case of enterprises in places where you don't have hydrological information, rain, rainfall, precipitation, and so forth, consistently, or where you have those a complete absence of those kinds of information. The second one is when the dams are old and have no documentation anymore, what kind of assessment or study or survey do you adopt in order to update those security and safety conditions in those structures and their dependencies? And the last question is, what is the method that you use in order to simulate the generation of inundation flooding spots all over the valley downstream from the dam in a hypothetical cases of a breach? How do you calculate the prevention of loss? Which is also a question similar to the one that Stephanie made before, which was beyond the classification, do you also use the classification from the work of Share of the full level of water? Do you map that in a wider scale?
Okay, so one of the things that we've been working with Anna and Josimar and Bill Empson here at the Corps is, what can we do when you have this case where you don't have any hydrologic information for the dam that you're evaluating and no inundation maps and all that? I don't know what that answer is right now. I think that we I guess are aware of this issue, that you might not always have this type of information, and are trying to determine if there is information that is maybe generated by one of the government agencies, or if it's in a database in your dam inventory. I don't know. I don't know that answer, but it's on our minds, and I know it's on Jose Maia's mind that we don't always have this information, and what can we do? What can we provide that could help us alleviate when you don't have all that information? When it comes to old dams and potentially not having all the data that we in the Corps are used to having, I think you would have to do site investigations. So you would have to do field inspections, and you would have to have a certain criteria that is met. That's another example of when we would probably need to make adjustments to how we define these evaluations between our inventory and your inventory, and how we're going to do screening. So I think maybe boots on the ground, eyes on the dam kind of thing would have to be provide a certain amount of information when it comes to some of these dams where no data is available. And there also could be multiple phases, right? So it could be that maybe potentially there's not enough information to even do a screening. We haven't really thought that far ahead of what that criteria would look like, and whether it would need to be phased as like having different levels and different approaches depending on the structure and how much information is available. But that could certainly be a possibility. Method used to simulate inundation for, so we use dam break models to look at inundation. And like I said, we use those two different scenarios. Beyond that, I'm not a hydraulic engineer, not the best person to really go into any more detail than that. But again, I think there is a general awareness that for some of these dams, that is not information that that you guys would have at hand. And we do need to think about maybe how we would evaluate dams where less information would be available.
Assim, a última.
Okay, so now the very last question. What is the maximum period estimated by USACE in order to deal with the dams that are classified as risk 1?
I don't think there is a written period. I've never seen that written down, that there has to be action within a certain number of days or months or years or anything like that. But this is a very small part of our risk evaluation process. So really, if we have a DSAC 1 dam that was screened through this process, it then went into a more in-depth risk evaluation where we created new models, did new analysis, potentially new field investigation, new field data, and really did an in-depth evaluation of those failure modes. And then it goes into a study where we evaluate how the dam would need to be modified. So it's a multi-year process. It's not meant to be something that you go into modification based on screening. So there are other levels and other requirements that are needed before we go and modify a dam. But all those steps have to be followed regardless of whether it's a DSAC 1 or a DSAC 3. But we would prioritize the DSAC 1s for resourcing, funding, and schedule.
Obrigada, Gabriela.
Thank you, Gabriela. Well, so we are a bit over time, and some questions unfortunately couldn't be answered because we have had a lot of them. And if your question wasn't answered, please get in touch so we can forward them back to Gabriela, and she will, I'm sure, make her best effort to answer those questions later on. Okay, so I really appreciate you all being here, especially Gabriela, Lyvers, for being here, bringing so much information, which is so relevant for us, and also for us to assess how can we own that experience that USACE is sharing with us for our cases in Brazil. So I I should mention that on the 29th of March, we will have the next edition of this, which will be about internal erosions. Next week, we are going to send you the link for enrollment. So this is also going to be a seminar like this one with 2 hours available. So we hope to break the record again. In addition to the one we broke yesterday, we had more than 60 people online participating in this event. This presentation will also be available on YouTube, on Anna's YouTube channel, and if people, for people who have not been able to participate today, this will be available. So again, just to make sure you know it, the 29th of March, internal erosion of dams. Gabriela, once again, on behalf of Anna, I really appreciate you being here. And we see each other again, I think, on the 29th. I don't know if Rogério would like to add anything. Not at all, Tawana. I just want to say thank you to everybody who's here. Thank you for being here, and let's move forward. Again, thank you, Gabriela, and all of the USACE team. Goodbye, everybody. See you next time.